So let's have a look at this trigonometry question. It says here, find the length of side A. Here's length of side A. And to do this, we're going to use the law of sines. So before we start, let's have a look at the law of sines. From this math textbook, calculating oblique triangles, and this means it's not a right angle triangle. We're going to use the law of sines. And the law of sine states, here is the equation for it, the law of sines. And it's the length of side A divided by the angle of sine A is equal to the length of side B divided by the angle sine B. And that's equal to the length of side C divided by the angle of sine C. Let's look at a triangle. Here's a triangle, an oblique triangle. And you will note capital letters represent the angles. Capital letter C is this angle. Capital letter B is that angle. And here is capital letter A for this angle. Opposite the angles are the lowercase letters A, lowercase letter B, lowercase letter C. So for angle A, opposite it is the length of side B, lowercase b. And here's angle C. Opposite it is that length, and that has lowercase c to represent that length. And here is angle A. Capital letter A represents the angles. Opposite it is the lowercase letter a, which represents that length of that side. And the same with this oblique triangle. So these are not right angle triangles. So I'm going to take this equation right here and write it down in our word problem. It is the length of side A, little a, divided by sine of that angle, A, is equal to the length of side B divided by sine of that angle B, is equal to length of side C divided by sine of the angle C, capital C. To use this, we don't use all three of them at the same time. We use two at a time, either these two, or those two, or these two, depending on what it is we are given. So let's have a look here. And immediately I see I have a capital letter A, and that would be incorrect. That would be confusing, to say the least, and how I'm going to solve this using this equation with that capital letter there, and I have capital letters here representing the angles. So this ought to be little letter A. Since that's little letter A, then I'm going to call this one capital A. And the other two angles, I can arbitrarily call them anything I wish, B or C, doesn't matter which one. So if I call this angle B, and I can call this angle capital C, that means the opposite side, that length right here, then becomes little c, or lowercase c. And the length opposite angle B would be lowercase b. I'm going to redraw this triangle right here like this. Something like this. This angle in here is 80 degrees. And the angle here given to us is 60 degrees. And we have angle alpha. This would be alpha. Well, we can calculate alpha. Internal angles of a triangle, any triangle, must equal 180 degrees. Internal angles in a triangle equal 180 degrees. So these three must equal 180 degrees. Therefore, 80 degrees plus 60 degrees plus alpha must equal 180 degrees. You want to solve for alpha. Those two added together is 140. plus alpha is equal to 180 degrees. Subtracting both sides by 140. Alpha then is equal to 180 degrees minus 140. Therefore, angle alpha here is equal to 40 degrees. And I've already called this here A, angle A, according to what I wrote down there. So angle A is equal to 40 degrees. And I call this one here B, and this angle C, capital C. And we're asked to find the length of side A. It says capital A because the drawing was originally capital A, but this is the length we really want to find. And if that's capital A, then this will be small lowercase a, so I'm just simply going to change that to lowercase a. So we want to find that length. And now everything here using the same variables as the equation. And this is very common how the equation is written. Lowercase letters for the lengths, capital letters for the angles. Now let's see what it is that we know, because we can only use two of these equations with respect to each other. What is it we want to find? We want to find A. This is length C. That's C. This is length C. If that's capital B, this then would be length B, and length B is 30 meters. Length A we don't have, and length C that we don't have. So looking at our equation and looking at our triangle, we want to find A, this one right here. And the sine of A, we know what the angle A is, 40 degrees. So we know what this one is. And let's look at B. Here's the length B. We don't know what the length B is. We do know the length or the angle of sine B, but we need to know both of them because that's our variable, that's our unknown. And if we look at this one, length C. Oh, nope. Length B we know. And length C we don't know. And sine of B we do know. And going back now, this length C we don't know, and the sine of C we do know. So this one we can't use because we don't know what the length is for C. And we do know the length B, and we do know the angle B. Those two are knowns. This one is known, and that's the one unknown. So we're going to use these two. We're writing them down here. The length of side A, which we don't know, is equal to sine of the angle A. That's equal to the length of side B divided by the angle of sine B. Now let's put in the numbers of what we do know. We don't know what A is. Sine of A, here's A, we said A was 40 degrees. Sine of 40 degrees is equal to the length B. B we said was 30 meters. 30 meters. Divided by the angle opposite, which would be sine of B, or 60 degrees. The equation is now set up. We just have to do a little bit of algebra in order to solve for A. A couple of ways we can do this. We can cross multiply, or we can just simply take sine 40. It's being divided here, so we can multiply sine 40 on this side, multiply sine 40 on the right hand side. It would look like this. Sine of 40 degrees times A divided by sine of 40 degrees is equal to 30 meters divided by sine of 60 degrees. But whatever we do to the left-hand side, we have to do to the right-hand side. So we have to multiply the right-hand side by sine of 40 degrees. Over here on the left, the two will cancel out. And that leaves me with the length of side A is equal to 30 meters times sine of 40 degrees, everything divided by sine of 60 degrees. So let's do this one at a time. Length of side A is equal to 30 meters times, what is sine 40? Now you can do all of this in the calculator all at once. But I'm going to do it step by step. Sine of 40 degrees, I'm going to put in here sine of 40. Sine 40 degrees is equal to, I have a number, 0.64277876. Now this has units, degrees. Once we do the sine of 40 degrees, the units drop out, and this becomes a unitless number, dimensionless number, or unitless number. So it's just a number, like number 5, number 6, 7, has no dimensions to it, no units. Everything divided by, and we're going to do sine of 60 degrees, same thing. Sine 60 degrees is equal to, it says root 3 divided by 2, that will be an exact value. I'm going to change that to decimals. And it's 0.866025404. And same as before, you take the sine of 60 degrees, it becomes a dimensionless number, no units. So we have 30 meters times a number divided by a number. Let's do this now in our calculator. And I'm going to go back and go back to the original one here. It's 30 times sine 40 equals, divided by sine 60 equals, and the number, as you can see, the length of side A is 22.2668815. 266.81597, and the unit that's left over, there's no units here, is the meter. And that makes sense because this is in meters. So any other one of these lengths has to also be in meters. Last thing we need to do is reduce this to proper significant figures. How do I find out how many significant figures I should reduce this to? We go back to the original question. And we see that all the numbers given to us here is the two significant figures, 1, 2, 1, 2, 1, 2. I'm going to make the assumption that there's a decimal point here, making those zeros significant. So 2 sig figs here in the original word problem. Therefore, our final answer can't be any greater than 2 significant figures. Therefore, length of side A approximately equal to, reducing this to 2 significant figures, 1 and 2. Look at the third one. Less than 5 round down, greater than 5 round up. So less than 5, we're going to say 22, and the unit is the meter. Length of side A is approximately 22 meters.